Thank you for allowing me to speak here. It's basically Jozef's fault, I think. This is work together with Katja and Floris. I don't see Floris in the audience, but Katja is in the back. I didn't put their affiliations on the slides, but you surely can Google it, I'm sure. Okay, so what is this about? Last week or two we had some kind of rogue work group. So Michael is always aiming for work groups and aiming to avoid them. And then we had this little thing on the side without being on the magic spreadsheet. So that was kind of funny. And that was to do a successor to the top 100 theorems that you probably all know about, but I'll tell about it. So what is this about? So these 100 theorems that started with this page. So I didn't have any involvement with this page. This is created by two people called Paul and Jack Abbott. I tried reaching them at some point. I was not successful. I don't know whether they still exist or are alive. I think I read somewhere they're brothers, but I'm even not sure about this. And at some conference in 1999, they made a list, asked people for nice theorems, and made a list of 100 nice theorems. And someone pointed this out to me, and then I found this very funny because I had this little book with the 17 proofs of the world, which were 17 formalizations of the rationality of the square root of 2. In Nijmegen at the time we had a formalization project for the fundamental theorem of algebra, and they were the first two. And in this first, the prime number theorem, of course, was famous because Jeremy first formalized the elementary proof, and then John formalized the analytical proof. So these were all examples that were used all over the place for formalization. So okay, let's try to check which have been formalized. So I did this. That's this page. And then John Harrison liked this game, and he started mailing me a formalization every night. So the great theorem for today is that there will be another formalization. This guy is very good at formalizing. And then it turned into some kind of competition. Which one has the largest list, and here are the counts. Together there are 99. So the only one that has not been formalized is from Hausdorff's theorem. And at some point I would like to have some little workshop celebrating this called, I got 99 theorems, but Fermat ain't one, because Fermat is the only one that's not there. I wanted to have it here, but John Harrison couldn't come, and because he was the one who initiated this whole thing, I said, okay, let's postpone this. So, many times people have been saying, you should extend this list. What are you going to do next? I got mail, and then always it was like, yeah, but I didn't make this list, I'm not going to make another list. This was just something I didn't do anything. I just was post office. So people would mail me, I had formalized something, I would add it to this list, and that was all I did. I didn't even look at it. Like, if they didn't actually formalize it, then someone else will tell me, and then they can find it out among themselves. That's not my problem. So I didn't know very well what to do with the next list, but then I discovered this Wikipedia page, which I was not involved with either. It's called List of Theorems. And that's a nice list of theorems. So I said, I found another list out there on the web. Let's do the same thing for this list, right? And what is kind of interesting here, if you read, this is just a screen name from yesterday, it says it should not be alphabetically, but it should be sorted by subdiscipline, and I'll get back to that in a second. So if I scroll down a bit, then there are about 1,200 theorems here. And as you can see, it's not just mathematics. There's theoretical computer science, there's even politics. This rationality theorem is the only one that doesn't contain a link to a Wikipedia page, which made our database a little bit more interesting. Yeah, this is the image you should have of this list. And if you Google for list of significance, it will be the first. Okay. So this is 1200 theorems, and yesterday Katja told me, oh, this soon will be more than 2000 theorems because she was able to query Wikidata for Wikidata identifiers of theorems, and she found, I think, more than 2000. So maybe she'll try to push this to Wikipedia and we'll have a big paper. I don't know what's going on.
Yeah, that was thanks to Lloyd's, just so I don't get too much credit for it.
Okay. Okay, so that's the whole, this was basically the talk, right? I mean, we're going to do the same thing with the top 100 for this. So if you look at the source of this Wikipedia page, that's kind of important later, then it looks all like this. So you have the name of the theorem into square brackets, then in double quotes to get it italic or something, I suppose, the categories. And this is basically the source material that we built the database of these theorems. And as you can see, the rationality theorem, I have no idea what theorem this is not in double brackets. And there is a big Wikipedia page called rationality choice theory or something like this, which I used as the identifier for this subject. Okay, so Katja generated a website out of her database, and currently there's one formalization in it. So we did it together with Floris, and as a prototype, we added one formalization somewhere to how are we going to encode this. And of course, Floris has the independence of continuum hypothesis project. So currently, if you go to this 1000 plus github.io, there will be one theorem. But yesterday, there was someone from the Lean community who said, oh, this is interesting, I recognize this theorem. So I suppose by tomorrow there will be a lot of Lean. And the top 100 page really gave credits, but this I wanted to be more like a spreadsheet, so there will be just 6 columns with one letter in it for formalization. And then Mario, when I showed this to him, said, but I want the credits. I did all those formalizations for my lot of top 100 videos because I like to see my name there. He didn't say it like that, but I think it was something like this. So what we decided is, because you made it, if you put your mouse over the letter, then you get a pop-up thing that shows your name. And similarly, there's a MSC classification over here. If you put the mouse there, it explains what zeros means, which is logic and that's really. And then you can click on all theorems here, and then you get the whole list, 1198 entries at the moment, with no formalizations yet, but that will change. And this is the same part of the list that I showed on the Wikipedia. Okay, so I said this was a talk, so let's summarize what we have in 2 slides and what it is. So we have a target list of theorems, we have a database now with no formalizations in it, but with all the information that's needed to store this information. We have some scripts and tables, but that needs more work. We have a Git repository, which is public, it became public yesterday. We have this web page, and we have no logo, and that's kind of a struggle between Katja. I mean, she likes logos, and I think logos look amateurish, so I don't want one, and we will see in the end who will win this fight. She likes making logos, she makes nice ones. Okay, so what is the difference with the top 100? Oh, that's not what I want. Yeah. What's the difference with the top 100 thing? So, there are differences. So this 100 theorems was frozen. This is what it is, we're not going to change it. This is the aim, everyone works towards that goal. This is not a frozen list, because we plan to update our database when the Wikipedia site, if someone turns it into 2000 instead of 1200 theorems, we will turn ours also in 2000 theorems.
So will people be removing things from Wikipedia?
That's one of the things on one of the later slides. That's something that we thought of ourselves as well. Okay, so for me, the 100 theorems was a museum. It was like, okay, it was for mathematicians to look, what does this formalized stuff look like, right? That's why we had all those pages with statements on it. That, okay, what does lean look like? Oh, it's camel case all over the place. What does Holite look like? It looks like ASCII art. I mean, it was for me an idea to be a showcase. And really about systems, like what does lean look like? What does cock look like? And it turns into a competition, which I kind of didn't intend, but of course, it was fun in its own way. And it links to list of statements, like every system has a page with all the statements that have been formalized on it, which for a showcase is the perfect thing, right? And I was just the maintainer. People would mail me, then I would wait 4 months because I'm very bad at replying to mail, and then I would edit it into a static HTML file, and that was all that. So if I've destroyed my HTML file, the whole thing would be gone. I would need to go back to a backup. So this is quite different. So this for me is really what is there. So people always ask me, this theorem, are you aware whether that has been formalized in Coq or Isabelle? And then I generally know, like the sum of square things, I knew it was in Isabelle, I didn't remember it was in Coq, but what is available where? That's basically the purpose for me of this project. So you have some theorem, you want to know in what systems is it available, you can easily find it. And for me it was also about libraries, and at first I just didn't want to target systems with libraries. Like what is in masslib, right? What is in masscomp? What is in the MML? But then people said to me, but there are these huge projects that people work very hard a long time on one specific theorem which doesn't end up in the library, but it becomes a project of its own. And of course you want to show this, you want to mark in your list for this theorem. It's crazy to leave that out because it's not in the official library. So we went back to systems. And then I would like the links to go directly into the libraries. Like you have the Radon-Nicodemus theorem, you click, and you don't go through lists and stuff, but you just go right into masslib. Here is the that's the image I had when I designed this. And then finally, these 100 theorems I did by myself, but the 1000+ theorems. Basically, for every system, I want someone that takes the responsibility for this. And because it's Git, probably the whole world will take the risk, but we will get PRs. Floris is the one who is doing lean, and he said, I'm not going to do anything. I'll post on Zulip and then I'll get a PR and I'll look at it. It will have been done. Okay, so some technical details. So every theorem basically has 2 strings associated to it. There is the double square thing from the page. Yeah.
I have a question on the premise.
Okay.
So, for the list of 100 theorems, you were the one checking that the proposed candidates was actually...
I was just post office. I just blindly put it in. Someone will complain, and if they complain...
This is actually a proof of the actual theorem.
That's good.
You trusted the authors that...
I trust people will look at each other and complain. And that had never happened. Maybe there's fake data.
But then, the question might be a bit more complicated with this more diverse...
That's true. That's true, but I...
check that the candidate is actually a proof of the theorem is supposed to...
Sure. But I hope there will be some community. And so, with this list of 100, I was the one responsible. And like I said, people will complain and then they can fight it out among themselves and I will watch. It was not a serious project, it was just for fun. Here, it's the responsibility of the maintainers for the system. So if someone says, I did something in lean and Floris is the one you can talk to, like, Floris, what did you do? You allowed this in the list and it will be taken out. I mean, that's the nice thing about it being a more dynamic thing.
So I suppose you're saying that first you check if it's on the archive format proofs, for example, and then if it's, you probably that's a prerequisite that it should be on the archive format proofs or on mathlib, and then you post it.
Well, the maintainers for the system should do that work, but yes, basically, yes. But let me first show some more details. Okay, so basically these strings probably are not very stable. Because, for instance, this Radot theorem, there is no prime in what's actually displayed on the page. So these things, if there's a vertical bar, the left side is the thing in Wikipedia it points at, the right side is what is being displayed, like /href in LaTeX source code, and there's no quote there. So suppose someone adds the quote, like, okay, we fixed this, then the string is not the same anymore. So internally, we use Wikidata identifiers for this, because we think that will be more stable. Okay, and these are the first three that start with an R, and you can see this fits very nicely. But of course, it doesn't fit for all of them. There are issues there. Yeah.
So who decides if I change Bolzano's theorem to Bolzano's Weierstrass theorem, whether the Q identifier changes or not?
Well, so there's an update script that I still haven't finished, but the idea is that will say, here is new string. Do something with it, and then I look at the page and compare. I mean, that will be manual work.
I guess my question is, how does this Wikipedia title, which has just changed, correspond to the Q wiki data thingy?
The Qs for some of them are wrong, I'm sure. But it's just, we need some internal tag. So we just use what's some ad hoc mapping that I will explain in a second. And if there's a better one, someone says, but actually this Q is better than what you have, we change it in the database and then it's better. I mean, these Qs don't need to be the same for eternity, but they're probably like more stable. Yeah?
I think there's more to this, because the French Wikipedia is also pointing to some Qs, and they might be the same as the English ones.
The idea of those, but like I said, these Qs are not, I'll show some Qs that are wrong in some sense. They're not really meant to match exactly the theorem. We just need a tag in our database. And so if the French Wikipedia points to a different one, maybe it's a better one. I mean, the Qs are language independent, right? So they're more the concepts. But we needed some short labels instead of these huge strings with all the spaces and stuff. Okay. Okay, so the database is not a real database, it's just a bunch of files. And it's MD files, markdown files, in a directory underscore theorem. The underscore in the markdown is because Katja needed that for her web generation stuff. So this is basically what it looks like. There are 1198 files here. And one thing that's kind of interesting, this Q identifier occurs twice with an X here. And I'll come back to that in the next slide or 2 slides or something. So what does a file like this look like? And again, the 3 dashes and so are needed for this page, web page generation. So it starts with a comment to be readable what it's about. So this is the one file we made. And the other files are there, but there is no formalization in it. Then we have the Wikidata tag. We have an MSC classification that for many theorems probably will not be correct, but we did some rough approximation to have a start of the database. Then there is a list of strings in the Wikipedia page that correspond to it. So by taking these files, we can map this to that. And then for every prover, we have a list of formalizations. And so the interesting fields are Wikidata, MSC classification, Wikipedia links, and then for formalization, D6, and that's the subject of the next slide. So I talked about this to Sander Dame, and he said you should also have things that just have the statement formalized. That's already a lot of work for real mathematics, and it will be some kind of incentive for people to formalize it. So you can say it's fully formalized. It's like the border in these diagrams that the Lean people use all the time. And so those are the 2 values that you can have there. Then the library, there are 3 possible letters, S, L, and X. It's like the sizes of a t-shirt. Floris wanted M because Maas Lib starts with an M, but I wanted L, so I push L here. So S is the standard library of the system. Like in Lean Core, I think it's called in Lean. If you load the system without loading any extra libraries, that's what you get. If it's there, then it's S. L is the big library of the system, and we have 6 systems, and these are the 6 libraries that we're thinking of. So in Nijmegen we had the Seacorn library, it's not there. There probably are other big libraries for Kok, but these are the main libraries for it. And then X is something that's not in S anyhow. Then there's URL, that's the thing you go to when you click the letter in the web page. And there are 3 optional fields: identifiers, authors, and dates. So identifiers is just what is the theorem called, and there might be more theorems, more lemmas in the formalization that correspond to this theorem, so you can have a list of them, like we have different versions or something like this. Then there's authors, and there's dates. And then there's also comments, but...
Right, but there's no authors of the theorem, the authors of formalization.
No, because basically the name of the thing will point to the Wikipedia page. So there, when we were discussing this, first wanted information about the theorem in the file or someone. So I don't know who it was. Someone else that, and that's not the point of the thing. This is just pointers. I mean, the information is on Wikipedia already, so we are not going to duplicate this. Okay, so these are the 6 systems in the order of the top 100. I didn't talk to anyone yet. This is really, hands. Yeah.
So a question on the previous slide.
Yeah.
So most systems have some kind of standard for naming the various libraries. Shouldn't you record the identifier of the library?
Yeah, maybe we can have L1 and L2 at some point if that turns out.
I want to do like the actual names in the system.
Yeah, but I want the web page to be extremely sparse. Just letter. So if it's both in L and another version in X or something, you can have L, X or something like this. But I don't want matlib, and it gets too fluffy for me. That's my personal taste. Yeah.
For the authors, you should allow optionally to have ORC IDs, because those are ORC IDs,
Yeah.
because they're more stable than names.
I mean, we didn't put this in double quotes, these identifiers and authors. Maybe, I mean, this is all very malleable because this is 1 week old. I mean, what people put in the identifiers and authors, that's the responsibility of the maintainer of the system. So it might even be system dependent. In the identifiers, do you put the namespace in front of it? I don't know. Do whatever you like. I mean, this is just, do we put this in the tooltips? I don't know. I mean, maybe it looks nice. Yeah. But this is the kind of information that's kind of, so, both other hands? Okay. So I should be mailing those 4 people for those other systems. And I'll do that when this is on YouTube. So here's the YouTube video. So hi guys, the reason you're watching this is the reason that I mentioned. Okay, so how did we get the initial Q identifiers? We took the string and then we extract the link, which is the left part. And then Wikipedia has redirects. So in this case, there's a redirect from S cobordism theorem to H cobordism. And then there's this Wikipedia page where the spaces get replaced by underscores, and every Wikipedia page has a Wikidata identifier. So we just took the Wikidata identifier for the page that this thing pointed to. And maybe it's the wrong one, and in fact in this case it is the wrong one, because Q, this big number, is H cobordism, not S cobordism. So, yeah, I don't mind, I need a tag. If there turns out to be a Q identifier H cobordism, we'll change it, right? So this was how we got our initial 1200 identifiers.
I have a naive question.
Yes.
So when dealing with cobordism, this is a good example from topology.
I have no idea what cobordism is.
I would guess so. Yeah, there are slight version differences in different definitions.
Yeah.
So you need also a tag to this is the definition.
No.
No? No.
People get one pointer for one system. They go through the pointer, they find what's there. I mean, you can have multiple pointers if there are multiple versions of this theorem, because if I go back, this thing is itemized, right? I mean, you can have more than one entry here. And in the table it will be x, 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 x for all the different versions. Mm-hmm. This is just, like I said, it's pointers. You go through it and there will be comments in the file that explain which version it is. That's how I imagine it. I mean, like I said, this the top 100, I was the only one. I could do whatever I like. Now there are people involved, so who knows where it will go. But this is how I see it.
I also.
But I don't want this kind of information. There is the comments field, which I didn't put on the slide. You could put something in the comments field. This is the version with this definition. But yeah, what are you going to do? This comments field won't be on the web page. So.
Yeah. It looked like your slide was at the top talking about the theorem, at the bottom talking about the definition. It looked wrong.
Yeah, but like I said here, it doesn't say even theorem. It says just a notion. But I needed a tag. So if there is, so I said I'm not going to change this Wikipedia page. There is one thing that is not a link. I'll deal with this. I'm not going to fix that because it will get back in a new version. I'm not going to introduce new Wikidata identifiers myself because I don't know what's there. Maybe it's there already, it's duplicated. I'll take what's there. So those worlds are kind of, I'm doing the autistic thing. I'm not going to expose myself to those people. I needed, this is just a label. And the fact that the label doesn't match in the Wikidata sense is kind of not so relevant. But you're right to remark on this. Okay. So what we do with this S-covariism theorem, we add this X suffix to show that it's actually not the thing, because there is also an H-covariism, was it H? Yeah. H-covariism theorem on the list that gets the tag without a suffix. So, and if we put an ID suffix here, so that's also in the name of the file, then we have this little comment that explains the Wikidata, so you can see what the tension is there. So we only added these suffixes for duplicate identifiers. We went through this pipeline for all the 1200 theorems. We got 1200 QIDs. There were some duplicates, and there were three possibilities here. Either it was just two different names for the same theorem. And I don't know whether this is a good example, but I looked on this webpage and it says it's also known as the Haankomen curve theorem. So I suppose if I believe what it says there, that it's just two different names. So in that case, basically there's just one file and we have two Wikipedia links in it below. And in our table, we just use the first one. Then there's this H-covariism, S-covariism thing. The S dash is longer than the H dash for some incomprehensible reason. And so I went through all these duplicates, and generally one is the real one, and the other one is related or corollary or special case or generalization or predecessor or stuff like this. Then we use X. There's an extra version of it. But sometimes the Chow theorem and Riemann's existence theorem both point to the Wikipedia the notion algebraic geometry and analytic geometry. Well, that's not really an appropriate thing for these theorems. So then we did A and B, like, okay, we have A, B, C. So there are something like 20 of them. This is not a big thing. I did this manually. I went through it, read all the Wikipedia pages, decided, okay, this is going to be A, this is going to be X. Okay, then we also have the MSC classifications. Like I said, this was a rough approximation, so I hope we get PRs fixing this. Many theorems will be in more than one category. I just want one category in my list, so there should be, someone should decide what's the primary one. If there is a quarrel about this, we will see. I only want 2 digits, so what I did was I took all the different subjects, made a list of about 250 of them, opened the website, searched the MSC classification, and just randomly, not randomly, but try to say, okay, but for instance, algebras, I put 17, I forgot what 17 was, probably the theorem that has, some of the theorems that have algebras are in different categories. So this was just to fill the database with some initial version. And if you go to the web page, you can click on sort, so you can see. And unfortunately, if you do this, it starts with 0, 0, which is other. So it starts with a lot of physics, because physics is an other, I think. Okay, so I talked to various people about this, and these were some things that have been brought up. People might add stupid theorems to Wikipedia to get into this list. The Wikipedians might not like that so much. So we had some disclaimer in the README, don't do this, but yeah, what can you do? Then I wanted the links into the library, like I said, but Flora said I'm not going to do this. because the library is too changing and I need to change those links all the time. I don't want to do this. And I said, but I don't want to go to a page with a list on a page. I just want directly to go where it should be. Can't you do something with a redirect, that you have some page with the Q identifier and it redirects to where it should go? Because if you maintain this list, you need to maintain that kind of information anyway. I don't know how that will work out, but that's a question. People always want to stuff more stuff in those files. Can't we have more detailed MSC classifications, like in Planet Mars, there is this kind of information. But then it will not be so clean. Because for some theorems it will be there, for others it won't be there, it will probably not get fixed. It will be messy, and I don't like mess. So if I'm in charge, which I'm not, then no. Mario said, the nice thing with top 100 is we're at so many percent and we're working. So suppose we do this with this list and then Katja comes in and suddenly 2000, we're way back again. Can't you freeze the list? I don't know. I want to be able to say, this is just that list, end of story. Okay. There's the question that Johan asked. Theorems that have been won in the list, should we keep them? I discussed this with Sander, and the current plan is yes, but only if it has been formalized. And then we just keep one link. So we just take the first link in the file, delete the rest, and we keep it. And maybe in the table we can have a different color to show that it's not in the official list or something. And then everyone wants this to be an extension of the top 100. So shouldn't we include the top 100 things? Should we fill it with the top 100? We have that if, okay, Johan is completely on my wavelength here. So Mario really wanted this. Because people want to, but then I want, so people are, they have ownership over the system. If they want to do this, it's their system. They can be silly if they want. But I'm not going to do it. Right? So I think it's bad because it destroys the nice match, and the top 100 is not really theorems. There is one entry, the back integration. The back integration, what theorem is that? But I played a bit, so here's a spreadsheet that I made. So here are the top 100 things, and I went through Wikipedia again and found the Q, and I didn't put the Q in front because then my spreadsheet doesn't align as nicely. These are the Q identifiers without the Q for those 100 things. And it turned out for many entries I had no idea what's theorem. So you find some green theorem, but there probably are multiple green theorems. What green theorem is meant? I never even thought about this. And then I looked at the formalization. Oh, they formalized this one. Well, okay, let's use that Q identifier. And then I matched it with my database, which one there were, and you can see here, I forgot whether it's the Q identifier explanation or the entry in the list. I think the Q identifier explanation. And it turns out 60 of those Q identifiers were there. But one is formal, so that's the only statement, I suppose. So 59, and then one of these things is Euclid's algorithm, Euclidean algorithm for GCD. That's a nice thing, you can formalize it. But the Q identifier for that was Euclidean rings, that was the best I could find. And that's actually in this top 1000 list, but that's a theorem about the complexity of the Euclidean theorem, which hasn't been formalized, of course. So this 59, probably some of them don't match up well. So you could take this list and then fill the database with bad data. Maybe some people will do this. Okay, so that's it. This is what's there. 1000plus.github.io, you can go there. And I hope this will grow into something useful.
Thank you.